in the field of information technology and e-governance. Mr. Suresh Chandra has made significant contributions to the conformity assessment of e-government projects, focusing on critical areas such as functional performance, security, service level agreements, and project documentation. He has been instrumental in ensuring the security of mobile and IoT systems, as well as enhancing the accessibility of websites. As a member of several technical committees established by the Government of India, Mr. Chandra has played a vital role in the development of software testing and evaluation facilities. He has also led the preparation of training programs in the software quality and has served as a leader auditor for ISO. His vast experience includes developing certification scheme for e-procurement system and biometric devices, as well as setting up testing and evaluation facilities for national projects like the National Common Mobility Code. Additionally, he has authored guidelines for software systems testing and evaluation. Among Mr. Suresh Chandra's major contributions is his leadership in managing IT and e-governance initiatives at the STQC Directorate, overseeing multiple schemes such as IC3S, BDCS, NCMC, IoT, artificial intelligence products, and tool management systems. His involvement in high profile projects such as the Department of Post, GSTN, MCA 21, Passport Seva, and CCTNS, to name just a few, has greatly influenced and quality and security of India's public sector IT systems. In the international arena, Mr. Suresh Chandra represents India in the Common Criteria and chaired the Common Criteria Expert Group. He has also contributed significantly to the development of standards and methodologies in e-governance, cybersecurity, and IoT security, further enhancing India's position as a leader in the digital ecosystem. Mr. Chandra's recent initiatives include working with CDAC and the establishment of a national facility for IoT device security testing and the development of a cloud-based platform for STQC testing and evaluation. He has authored several research papers on topics like e-governance security, performance testing, and secure software products. For his remarkable contributions, Mr. Suresh Chandra has received numerous accolades, including recognition from the DGSTQC and the Kofi Annan Institute. Let us welcome Mr. Suresh Chandra, Scientist G, Ministry of Electronics and Information Technology, New Delhi, to take over the session.
Thank you. Thank you for nice introduction.
Sir, very good afternoon, sir. This is Dr. Chinnaya, coordinator, and Mr. R. Dinesh Kumar, co-coordinator from Department of ECE team. We are very proud of having you, such a high-profile scientist in our hosting organization, the FDP. We are all very proud to present to you to the participants. We hope that all the participants will have a very good interaction with you and utilize the golden opportunity provided to all. Thank you very much, sir. We are very happy to invite you once again. Thank you.
Thank you. So I can start now?
Yes, sir.
Okay, thank you. Thank you for a nice presentation. So my presentation will start with the challenges. We all know that security is the challenge. And I will give you the example of our normal world. When we want to secure our house, so what option we are having for security? So their option is you are having a wooden door. Wooden door sometimes you find is not sufficient. Then you are putting some steel door. Again you are thinking that this will also not be sufficient. Then you are putting some locks, and then there are multiple types of locks. So in our this digital world also we can apply the same analogy. To secure our houses, we are having the locks. Similarly, here we want to secure our VIP here in digital world. So I call in digital world something is there which is VVIP. So what is that VVIP in our digital world? So in our digital world, VVIP is nothing but the data. So whatever you are doing, whether you are on the Facebook, Twitter, or you are using some application in your office, everywhere you are generating some data, or you are using some data which is already generated. Now let us take the scenario where data is generated by some source, and this source maybe in my introduction there was like IoT was also covered. So I'm just taking the example of IoT only. Let us say there are IoT placed at some places, and their sensor is there, and from that sensor you are taking out some data. So data source is from the sensor, and that data may be of anything. It may be the image, it may be some water quality related thing or any other thing. So it's a data. So data is generated by that sensor. Now I have to protect that data. So that is the whole challenge. So that data become now the VVIP, and this uh, data criticality depend upon what type of data is generated. So when this data is generated, now you have to secure the data. Data will not reside there only in the sensor. It certainly it will transfer somewhere. So data is transferred through some network, because I can't store data locally. If you can store, there is a limitation for that. You can store to some extent, and beyond that, you can't store. So my first challenge is whatever minimum I am able to store. So whether that data is secure, and for that security, what is the mechanism? Available mechanism is that nobody can access. So you are having usual login password, but usual login password they are not sufficient. So what you are using for the some encryption mechanism for storage of data. Now that data, as I told you, I can store to some minimum level of data I can store locally. Now that data has to be transferred to somewhere, some other place, some other database server, or some other available mechanism, and that data will be transferred through some network. So when I am transferring the data through network, so whether my network is secure, so what type of mechanism I am having here? Again, encryption only. You may be using some SSL mechanism. So data is stored at the server side. So again, whether data is stored in clear text or it is in encrypted form. And then that data, it is not like that it will be ideal. Somebody will use that data. So for that, there are many applications, and those applications may be using that data. Now the challenge is in whole cycle, what is the lock here? In our physical world, we are having the locks we are putting on the doors. Simply here, what is the locking mechanism? So here locking mechanism is nothing but encryption. So we are highly dependent upon encryption only for securing the data. There is nothing beyond encryption. But challenge is whatever available mechanism we are having, like encryption, and we are having different types of encryption. Whether and it depends upon the uses now, where you will use which type of encryption, and depending upon the criticality of the requirement also. So like if the data is very sensitive, so there you may use some strong encryption, and somewhere you are finding that data is not so secure, so there you may use uh, some lower type of encryption mechanism. But whatever you are using, with time there are challenges, and now we are talking about quantum type of thing. So what I want to cover here, like whatever conventional mechanism we are having for securing the data, whether those conventional mechanism are sufficient, whether I will be able to safeguard my data. So that is our thought process. And in that thought process, I will try to cover some of the thing. So please keep in mind that I am not covering what is quantum and the various technique for that. My focus is toward security testing. So when these type of things are there, so how we can rely, how we can verify and validate security related aspects. So these are the content I want to cover here. So quantum mechanics, some brief, some basic of cyber security I have already given, and something you will find further in some of the slide. Quantum threat to cryptography, post-quantum cryptography, quantum key distribution, types of QKD, real-world application progress, challenges and opportunity, and at the end, conclusion. So, to start with introduction, as I mentioned you, the quantum computing, like classical computing, rely on principle of quantum mechanics. You all know that traditional computer, they uses the bits 0 or 1 for processing, but in quantum computer, it is qubit. Qubit can be both 0 and 1 simultaneously. So this is the new thing. Qubit can be both 0 and 1 simultaneously due to superposition. We will discuss. Another fundamental concept is entanglement. This is also very important factor for this quantum computing, which allow qubit to be interconnected, making the state of one qubit dependent on another. So we will discuss regarding this also. And then quantum gates manipulate qubits, providing a basis for quantum algorithm and computation. So these are the introductory part. And further to have further introduction, I know you all are expert. I'm just touching on some of the technology part, but objective is security, as I mentioned in the beginning. Quantum mechanics, as you all knows that it is divided in two part. Newtonian physics says that uh, this classical physics also we are telling, and we are calling this Newtonian physics also. Uh, depicted a deterministic universe where time and space were absolute. We all know that, and we have read many Newton's law on the basis of that. So objects move according to well-defined laws, and phenomena at all scale were believed to follow similar principles. We all know that Newton's law. Einstein, on the other hand, they are having some different theory. Einstein theory posited that time and space are relative and intertwined in a four-dimensional space time fabric. Special relativity declared that nothing can travel faster than light, and as object approach light speed, time slow down relative to observer. So, concept of relativity by Einstein. Now, the concept of superposition and entanglement. As per the superposition, uh, I think you are getting the full screen. I think there is something. Okay. I think there is some cut. So, quantum system ability to exist in multiple states simultaneously, collapsing to one state upon measurement. The superposition. In entanglement, there is a dependency between these states. One is related to the another, so it is an entanglement. And in the subsequent slide, you will find out. So this concept is mostly used. I think there is some issue. This. The particle become interdependent with the state of one directly related to the state of other over any distance. So this property will be used in QKD, and it is very useful. Together, superposition and entanglement underpin the powerful and non-intuitive behavior of quantum systems. So this we will see in the subsequent slide. So I'm just taking the example of different types of computer you all are using. So we all know that digital computer and quantum computer, and then the analog computer, and then parallel distributed processor, neural network, brain. So we are familiar with digital computer. We are moving towards quantum computer. We were in analog computer. Earlier we were using that. And this parallel distributed processor computer will also come in few years. So what quantum computing can do? So we all know that when we are using any of the encryption mechanism, whether it is RSA or SSL, etc., it is based upon the fact that factoring of large prime numbers. Like for example, it is 2048 or any other 10248, and would take millions of years on a supercomputer if somebody want to break this. If somebody want to compromise this algorithm, so it is not so easy to break these algorithm, and that is why it is mentioned here. It may take millions of years to break these type of algorithm. But on the other hand, you see that quantum computers could do this in a minute. So see the power of quantum computers. They can break this in a minute. So this is now one of the security challenge here. If I'm using the strongest type of algorithm, and that strongest type of algorithm can be broken within a minute by quantum computer. So this is a real security challenge now. And for secure communication, as I took the example of the data traveled from one place to another, and we are sending the data through some secure communication. You may be using transmission of encrypted data, or you may be using some SSL. Quantum-based networking allow perfectly secure communication. So any eavesdropping on the signal destroy the signal. So what is the beauty here? The beauty is in normal communication, anybody can interrupt my communication and take out the data, and he or she will try to decrypt the data. And to some extent, they are successful in decrypting the data. If the encryption is used, is a weak encryption. The data is not in encrypted form. They are using only some SSL, and SSL is weak. And if they are using encryption, that they are not using a strong encryption, so that can also be broken. But if they are using quantum based networking, then it is not possible. So this also we will see in the subsequent slide. Solve a variety of problems that are hard for digital computers. So another beauty is we are having many of the computation, they takes time, and for that we are making supercomputer, industrial computer. But by using this quantum computing, we can solve these problems very easily. So solve quantum mechanics, material science problem. What better to solve quantum mechanics problem than a quantum computer? But whether we can use a quantum computer at every place, it is not desirable and possible also. So for normal purpose, certainly we will be having dependency on normal computer like digital computer. If somebody want to simply type the letters, so why there is a need of quantum computer? Simple digital computer is sufficient. Orbits rely on quantum entanglement. So you see the example of superposition here. So here you can see there is a image of cat, and there is a two position. There are two position of the cat. You can see the superimposition here. On the right, you can see the superposition. The cat is available at two positions in the space. So quantum superposition and project management, I just taken some of the conversation. You can see how your quantum computer prototype coming along. So another person is applying great. The project exists in a simultaneous state of being both totally successful and not even started. So you see the example of Einstein. So it is available at two position, means project exists in a simultaneous state, means being both totally successful, but some of the attributes are there, they yet to be started. It is not completely complete, but some of the attributes are complete. So can I observe it? That is a tricky question. So certainly this is a tricky question, and it depends upon the requirement. For some of the requirement, you can say it is completed. For some other requirement, you can say it is not completed. So quantum entanglement, entangled particles seems to communicate state information instantaneously, even if they are separated by a great distance. And this entanglement will be of very useful while securing the data. So Einstein called this spooky action at a distance. So Einstein Podolsky-Rosen paradox or EPR paradox. This is also called the EPR paradox. So you can see here Einstein simplified. So entangled particles seems to communicate state information instantaneously even if they are separated by a great distance. So you can see the example, and you can see Einstein in three positions. It is as if there is a spooky connection that instantaneously tell one entangled particle the state of the other entangled particle, no matter how far apart they are. Basically, why we are discussing entanglement and superposition, basically they will be used for securing the data. These principle will be used. Quantum entanglement, that how do we know that there aren't just some hidden variable or hidden dimensions? Bell theorem proved the superimposed view of quantum mechanics. So math is a little hard, but we can demonstrate the basic idea with some coin. You can see the entanglement. The coin is available at multiple state, multiple positions. Same thing is here. When you are Having the coin, you can see the multiple positions. It can at one time it can be at multiple positions. So, but you still haven't told me what qubit is. What the heck is it? Qubit is a quantum entangled bit of information, just like bit is a 1 or 0. Qubit is two entangled state that either could be 1 or 0, but it can be both 1 and 0 at the same time. So this is the difference between the normal bit and qubit. Typically, qubit is an entangled pair of photons, electrons, or nuclei. The entangled part is the spin of the particle that we saw the coin. A spin up versus a spin down. We know in electrons in the orbit. The spin can be measured with an electromagnetic field and can be manipulated, flipped, if you will, with a pulse of radio frequency energy or measured via light polarizers. And this principle is used in quantum cryptography. It's a very important principle. When a particular time you are having all these electron positions and you are replicating the same position at other side. You are replicating the same position at other sides, so you are able to decrypt the data. So while you are encrypting, you are having some position, you are doing encryption, you are transferring, and you are having the same positions there, same position of electron there, and you are able to decrypt the data. So, qubit example, you can see it is not only 0 and 1. Here there are 4 parameters. Because the particles are in superimposed state, it takes 4 number to specify the state of these two entangled particles. So not two like 0 and 1 in our normal bit. Whereas in binary system, it is only 0 and 1. Now see what is the power of this quantum, why we are able to break the complex encrypted data within no time. So see the power, how much powerful is this quantum. A 64-bit computer can perform manipulation on 64-bit binary number at a time. A 64 qubit quantum computer operate in a space of 2 raised to power 64 dimensions, or roughly you can see the figure 16 into 10 raised to power 18 numbers to specify the state of quantum system. So using cleverly crafted quantum algorithm and quantum gates, you see the computation can happen in this enormous space in parallel. It is as if all the answers were being evaluated simultaneously, and the quantum system freezes out the right answer from the vast space. And it also means you double the power with every added qubit. So like in normal computation, in digital computer, if you want to double the power, so you are doubling the bits like 32 bits or 64 bit. But here power is doubled from 32 to 33 only. By having only one qubit, your power is doubled. To see the strength of quantum, power of quantum. So standard computing versus quantum computing, you can see we all are aware about these gates. But what is quantum? You can see here at right side, quantum circuit example. I'm just depicting one of the example of quantum. So what can quantum computers do? There are two examples here. One is source algorithm, an algorithm that runs on a quantum computer that finds the prime factor of a number n and does it in polynomial time rather than exponential time in digital computer. And you can see here what would take a normal supercomputer tens of millions of years can be done in minutes in quantum computer. And you see that most of the encryption algorithm, they are PGP and RSA rely on public key, which is composed of two large primes. Quantum computer could crack that encryption in a minute rather than millions of years on digital computer. Another is Grover's. Grover's algorithm searches an unstructured database. And with n entries for a marked entry using only, you can see O under root n query instead of omega n queries required in classical computer. So quantum communication, now we can conclude that quantum communication is unhackable communication, because if somebody want to interfere, somebody want to hack it, everything will be disturbed, your electron position will be disturbed, so it will not be possible to have a man in middle type of eavesdropping or man in middle type of attack when you are using quantum communication. And this quantum communication, as we understood now, it is based upon our entanglement. So it is very difficult to replicate the same thing. So anyone trying to listen to the communication, break the entanglement, rendering the eavesdropping useless. So if somebody is able to have it, then also it will be useless. So quantum communication, one example. So there is here you can see laser is there, device is there, Alice is sending the data. So some polarization is there of the data, optical channel is there, and at the above side detector is there. So data is available here, secure data is available here. But now the challenge is here. Now this is done, and we are claiming that eavesdropping is not possible. But how we can declare that? So for that, we have to do the testing, security testing. So in the security testing, you see here, I have to generate the key here by using this laser through polarizer, and then at the receiver end, I have to verify and validate whether the data is secure, and nobody can break this key, nobody can disturb this, eavesdropping is not possible. That is also required to be validated. So it is not the easy task for testing also. So for testing we require all these instrumentation, and wherever this implementation is there, uh, the same implementation may not be possible in the lab environment. So, in security, many of the tools will be required. At this moment, I am not aware any of the tool is available for this purpose for security testing of such type of devices. I think it will take some time, and we will be able to have some of the mechanisms to verify and validate that this is a impossible task. It is unbreakable, and whatever claim is there is the right claim. But parallelly with this quantum, now we are having, you all know that AI, AI is going with very fast speed, and there we can have the algorithm, we can have the AI mechanism, and we have to try to hack this quantum type of encryption by using AI mechanism also. So this will be the real challenge, quantum versus AI. So through AI, whether it will be possible, it will not be possible through some conventional mechanism. But by using some AI mechanism, whether we will be able to have some middle man in middle type of attack. So that is also a challenge. But all these things has to be verified and validated. Still, work is going on. Uh, Many of the institutes are working on this topic in this on this area. In India also, many of the organizations, many of the colleges, universities, IITs, they are working in this area. But still, we have to achieve many of the things. We are having many of the milestones which has to be achieved to verify and validate that really this is the secure mechanism. But whatever secure mechanism is this, if anybody can declare yes, it is certainly a secure mechanism. So at what cost? So we have to see basically everything while we are implementing any of the technology. So if you want to secure a data which is not so critical and you are using quantum is not advisable. And if you are using a data which is very, very critical and there you want to invest a high amount, then certainly it is desirable. So it depends upon the data criticality. But the other real challenge is while you are generating the data, that time some of the data may be critical. But after some time, after a year or so, that data may not be so critical. So I'm not saying every data is critical every time, but some of the data may not be critical all the time. And you are using sophisticated encryption, whether you will be able to have this data after a period, let us say 5 year, 10 year, whether you will be able to replicate this. It should not happen that whatever encryption is there, you are not able to decrypt the data. That key generation is not possible. It is not possible to decrypt it. So that means data is lost. So you have to see all the factors, all the scenarios while using any of the technology. So see why man in middle attack is not possible. You see, while key generator, there are electron positions, and those electron position cannot be recreated. So whatever we are reading, whatever we are discussing, it looks like a science fiction, but it is not a science fiction. Commercial QKD is more than a decade old. They are available in the market. Several companies are offering commercial quantum key distribution. I've taken one example, one or two examples. You can see ID Quantic, Geneva, Magic Technology, New York. So some of the examples are there. They are already there. Several other companies also have active research program, including Toshiba, HP, IM, Mitsubishi, NEC, NTT. They are working on it. In India also, many of the organizations are working. In defense also, some work is going on. In 2004, the world's first bank transfer using quantum key distribution was carried out at Vienna, Austria, using ID Quantic system. So D-Wave has quantum annealing computer. So 2000 qubit available now and 4000 bit available soon. IBM, Google, Microsoft, Intel, all they are working on quantum computer. Intel announced 49 qubit chip in January 18. Google 72 qubit quantum computer in March 18. So work is going on. And in quantum computer also, it is not like that all computers are equal. In quantum computer, there are different types of computer. So quantum annealing computer, analog computer, universal quantum computer. This quantum annealing is similar to our normal computer. The quantum annealer is the least powerful because it is least powerful and most restrictive form of quantum computer. It is the easiest to build, yet can only perform one specific function. So this quantum annealer has no non-advantage over conventional computing. This analog quantum will be able to simulate complex quantum interaction that are intractable for any known conventional computer. So it is powerful than the previous one. Universal quantum, it is most powerful, the most general, and the hardest to build. It poses a tremendous number of challenges also, technical challenges also. And all these quantum computer uses depends upon the your environment where you want to use this. So where you can use which type of computer. Now, what is our post-quantum world? What can be the post-quantum world? So there are good chance that quantum computer will be able to crack RSA 2048 within 5-10 years. Some encrypted data has a self life of 10 years. It may take 10 years to cut over a new encryption scheme. So that means we can break this in no time. So there is a confusion what to use for securing the data. Most encryption used today, they may not be safe in quantum world. There are encryption algorithm that are safe. Secure communication will move to symmetric encryption or hash algorithm or perhaps lattice algorithm. So QKD will likely to be more popular for most sensitive communication. As I mentioned earlier, all these techniques, they are not advisable to be used for everything. So you have to basically in security, it is like that you are doing risk analysis. And on this basis of risk analysis, you are trying to find out which is the data require highest level of security, which is more risky data where high level of security implementations are required. So on the basis of that, you can decide which type of encryption mechanism are required, which data are required, which type of encryption mechanism. So this type of mechanism, QKD type of requirements, they are not advisable for everything. They are advisable for some of the critical data. So post-quantum algorithm, some assessment, you can see here pre-quantum security level 128, post-quantum 64. So some comparison is there. And see the encryption, it is broken 128, broken 128, 128. All these will be broken in quantum computer. So we can't stop this. We have to think. We have to think post quantum. It may take few years to replace the infrastructure software because work is already going on. Many of the countries are working. Our country is also working. So the advice is we should also start thinking about quantum. We should not rely only on the encryption mechanism. But as far as our Indian concern, Indian scenario, Indian system is concerned, though we are talking about quantum computer, quantum cryptography, but still in normal encryption also we are not having that maturity. Why I am telling you this statement? Still, we are depending upon FIPS certified algorithm. FIPS 140-2, 140-3, and you know that FIPS 140-2, 3, it is not an international standard. It is a US standard, not international standard. International standard is 19790, and we are not having any algorithm on the basis of ISO-IC. Japan, I think they are having one or two algorithms certified as per ISO-IC. So ISO-IC is the international and open standard. FIPS is not the international standard, it's local standard. But all the algorithm, majority of the algorithm, they are FIPS based. And I'm not sure whether what these algorithm, whatever algorithm we are using, they are secure. Basically, these keys may be available somewhere. If some country is having such type of thing, they may be having these keys also. So as we are talking about quantum, as I mentioned, still we are not so matured in encryption also. In encryption, we are still thinking to have a crypto testing laboratory. Still, it is not existing. Yes, some work is going on, but still we are fighting on that. We are not having any certification mechanism. Still in India, we are not having any certification mechanism. In government, for defense purpose, some encryptions validations is being done. It is in SAC, DRDO. So they are doing something for defense purpose, but for normal public, normal uses, we are not having anything. We are having dependency on some other algorithm, some USA based, US certified algorithm, FIP certified algorithm. So our challenge are multiple. In crypto also, we were not matured. We were having dependency. Quantum, I don't know uh, how we will be successful. We will be having dependency on many of the countries, other countries, because of the known reasons. Because everything require the chip, and the chip we don't know how much time it will take. And if you want to produce any of the device, any of the instrumentation, they require chip. And when you want to have the chip there, you want to have all those encryption mechanism. So where you will have all those provisioning still, let us say you are working on quantum also, then also provisioning will be required to have these things in the device. So whether we will be ready for all these things, so we have to see the related infrastructure also beside this research work in quantum computing and quantum key distribution, QKD. So we have to see whether we are reliant on the related infrastructure which will be required. Why I'm telling you, your one of the thing may be secure, but whatever infrastructure you are using, it is not secure. So as I told you in the beginning, securely I was able to transfer the data at server by using highest level of encryption. But at the server end, the application which is using that data is not so secure. That application is vulnerable. So what is the use of such type of system? So same thing is here. We are able to have a strongest system, but our overall system is not secure. So the basic of cybersecurity focuses on protecting the system. As I told you in the beginning, it is for the protection of the system, protection of the network, protection of the data. As I told you, data is our VIP. And as we are having maximum reliances on the digital world, so we are generating the huge data now, and we have to safeguard that data. We have to safeguard that sensitive data from the hackers, from malicious software. And for that, as I told you, our normal lock is only the encryption, where we are using the technique like RSA or ECC type of technique we are using for securing the data. So this quantum computing is really a challenge to the existing cryptographic system. So as we discussed earlier, uh, algorithm on a powerful quantum computer can efficiently factor large numbers, threatening RSA encryption, which depends on the difficulty of factoring large primes. Additionally, quantum computer have the potential to break ECC by computing discrete algorithm much faster than classical computers. So RSA, ECC, all these are breakable in quantum computing. So post-quantum cryptography. So researchers are exploring post-quantum cryptography to design secure protocols resilient against quantum attack. So if we are having post-quantum cryptography, and then it will not be possible to break by using quantum computers. So some of the techniques, they are already in the market like lattice-based cryptography, hash-based cryptography, known for their strong security guarantees. So we have to protect the data, and for protection of data, certainly we have to rely on post quantum cryptography. So that will be the only solution in the future if we want to safeguard our data. And distribution, as we have seen, quantum key distribution, it is not so easy. It is not so easy to hack the key by using man-in-middle attack. It's not possible. So QKD is a secure method, allowing two parties to generate a shared secret random number. Based on the no cloning theorem, it ensures that key integrity by detecting any eavesdropping attempt. So it's not possible to hack the key by man-in-middle attack, by using man-in-middle attack. So types include entanglement-based and non-entanglement-based protocols. So QKD is based upon two protocols. It can be entanglement-based and non-entanglement-based. Now, challenge again, as I mentioned earlier, though we are talking about all these QKDs, but we require testing also. So, we require security testing, whether this QKD is really secure, whether QKD entanglement is more strong or non-entanglement based protocol is more strong. So, these testings are required. So parallelly, we have to see the availability of this infrastructure also, where our Ministry of Electronics, IT, and STQC also trying to build the infrastructure so that we can verify and validate all these claims. If somebody is able to produce some of the devices, then certainly those testing audit will be required, those certification will be required. So we have to develop all these facility. So we are still working in this area. We are not having such type of facility. Moreover, also I am not aware whether such type of testing audit facilities are available for such type of system, because this is the evolving stage. Same thing is there in AI system also. AI is going very fast, but if we want to validate the AI based system, so those tools are still not available. Now, the normal conventional tool like security attacking tool, they are having some vectors. By using those vectors, those signatures, they are trying to assess whether the system is having some known vulnerabilities. But the attacker, by using AI based thing, they can change they can change the scenario. They can change the scenario on the basis of protection mechanism you are having. So they will try to break your protection mechanism by using the AI based techniques. So reverse is also required. I require a AI based testing tool who can also change itself to verify that nothing is attackable, or whatever vulnerability are there, they are identifiable by using those type of tools. So work is going on in that direction also. So these are the really the challenges. These are the dynamic thing. And for that, if we take the example of India, in India, I will say we generally struggle for such type of thing because of the dependency on other countries. We are depending on many of the things which require from outside world. They are not available here. So because of that dependency, some of the things, some of the data are not secured. We can claim that we are using these things, but 100% we can't declare. In any system, as I mentioned, you chip are not manufactured here; they are manufactured outside. You may be having some design. Let us say you are having fabless. You may design some of the thing here, but fabrication will be required outside because we are not having fab here. So there also backdoors are possible. If you are making design, you are avoiding a backdoor in the design. But if fab is not there, so backdoors can be introduced at fab stage also. And those backdoors can be part of your system, whether it's a AI system or QKD system. Those vulnerability will be with you while you are relying on the technology, but overall system you will find that having some vulnerability. So that is our objective. So our objective is in overall system there is no vulnerability. So how to ensure that whatever you are using for QKD is totally secure, it is not having any vulnerability. So that is the basic objective. So type of QKD we already mentioned, it is entanglement based and non-entanglement based. And the examples, entanglement based example, they are E91, MDIQKD, DIQKD, they are available. Non-entanglement based, BB84, B92, SARG04, COW. You further refer, you can further can have the study on these QKD. Real-world application and progress. Quantum computing promises in cybersecurity has led to significant investment. Yes, certainly, it requires a significant investment by companies and government. And companies are testing QKD in real-world scenarios. So basically, here testing is not security testing. Basically, whatever testing is mentioned anywhere, everywhere, when somebody is developing, they are simply doing functional type of testing. It is working. That's all. But hardly anybody do that. Whatever it is working, whether it is securely working. So that is the missing aspect, and that we want to cover it. So that missing aspect is our objective. So advancement in post-quantum cryptography are making their way into industry standards. So many of the standards are in progress in ISO IC also, IEEE also. Challenges and opportunities. So quantum computing faces challenges like qubit stability and scalability, with errors arising from environmental interferences. However, these challenges open research opportunities. Now, see, you send the data by using QKD. Man and middle attack is not possible, but at the receiving end, you are not able to find the data. You are not able to decrypt the data because of some environmental factor, as mentioned here, because of some errors. So these are the real challenges, and I think with maturity, all the challenges will be covered, and we will be having a good system of quantum as key cryptography. So advances in error correction and hardware development are key to building more stable, scalable quantum systems. So see the requirement. Error correction and hardware development. We are not having hardware development. I am talking to you in Indian context. Is the key to building more stable. So we require a stable system, more stable system. And how you can prove this is stable? Only through testing. So that is what I was telling. You should have the stable system. So this is functional aspect. And whether this system is secure, that's the security aspect. Scalable quantum systems. This is the functional aspect. This system is scalable, enabling practical application in the future so that we can use this technology for our practical application. So these are the challenges, but there are solutions, there are answers for all these challenges. So with the latest research, people are working in that direction, and all those challenges will be uncovered. But all those technological changes, whatever are happening, they come out with some new challenges also. So that is why research is going on, going on. It's not the end for anything. So at the end, what I want to conclude is quantum computing is poised to redefine cybersecurity. Yes, certainly. We are believing that whatever is strongest encryption I am using, this is the most secure encryption mechanism, most secure data transfer is happening. I'm storing the data securely, but whether it is sufficient in quantum computer scenario, it is not sufficient. It is not safe and secure. While it presents threat to traditional method, it offers unparalleled security solution like QKD. So QKD is the solution, QKD is the answer for such type of problems. So we, as India, we have to work hard in that direction. The interaction of quantum computing and cybersecurity promises a shift towards more secure quantum resilient system. So we want a more secure system which is unbreakable by quantum computer also. So by using any of the strongest quantum computer, those secure data transmission cannot be hacked. So that is our requirement. That is our basic objective. So as I mentioned you that these technology, these system, still they are not stable. But parallelly, the testing mechanism, testing laboratory, whether whatever claim is there is the right claim, whether claim for security is there, whether it is secure, whether my overall system is secure. So these are the real challenges where many of the institutes are working, STUs working, IIT are also working. So I think we will be able to have something in this direction, something in this area. There is a push from government side also. So let us see the future, what will happen after 2 year, 3 year, 4 year, 5 year, because our technology is changing very fast. So thank you all from my side. This is all from my side.
Sir, Mr. Suresh Chandra, sir.
Yes.
Sir, your session on quantum computing was very excellent and informative for all the professors and scientists because it's emerging technology which changes the concept of everything, including security, because you are having a wide experience and expertise in security related, and you had headed various projects and committees in the national level and international level, as well as within STQC. We are very proud of having you with us, sir. Actually, it was very nice. All the participants enjoyed very well about your session, and we request all the participants to have interaction with the dignitary on the line. Please interact. Participants, you are unmuted. Now you can interact with the expert.
అది తీసాను వేస్ట్ కదరా అక్కడిక్కడ ఎందుకు ఇంకా
Sir.
Please, anybody?
Sir, hello.
Yes, madam. Yes, madam.
Sir, I have one query with the sir. Shall I
Please
ask?
discuss with it. You are welcome, ma'am. Sorry,
Yes.
Sandalai.
Good afternoon, sir. Sir, I'm
Good afternoon.
assistant professor over here in computer science department. I'm willing to ask one question regarding the real-time environment. RSA or EC is used because the encryption and decryption time is too much for EC and RSA and ECC algorithm. They take a lot of time for encryption and real world still they are used, sir?
Real world, yes, this is the problem, and I can give the example of like in e-procurement system, there is a requirement that all the bits should be encrypted. So when this requirement is there, and there the bit size very huge. So while doing the encryption, these mechanisms were taking a lot of time. So it was the burden on the system. So then what was there? Let us use some hybrid type of mechanism. So then many of the implementation we were getting for certification, their encryption was happening by symmetric technique, symmetric method, and key was shared in asymmetric manner. So that was the solution to have like these encryption are taking a lot of time. So you can use hybrid type of approach for that. Because in symmetric key encryption, key sharing is the challenge. So for that key sharing, you can use asymmetric type of encryption, and that will take less time.
Okay, sir. Okay, sir. Thank you so much.
Yes.
care arrangement hospital
Participants
Yes.
can interact with expert. Please have an interaction. Welcome, sir. Participant, otherwise you can post your questions in the chat box. Dear professors, we have a golden opportunity to interact with the senior scientist of STQC of India, STQC, Government Department of Information Technology, Government of India. Sir has held various key positions and has conducted various programs and also have undergone various training and is working the current technology related to securities. You can interact with him.
Good afternoon, sir. Sir, myself, Samita Tukran, Assistant Professor, Technical Institute of Advanced Studies.
Welcome.
I just want to know your inputs, your valuable inputs. That is there any specific role of quantum computing in IoT?
A specific role in IoT.
Ji.
Basically, as far as I think there is noise. There is lot of noise. So basically, it is not like where you can use this. Basically, the fundamental principle is, as I started my presentation with VVIP, and our VVIP is data. And this data can be generated by any mechanism. It may be IoT or any other thing. So at the end, we are securing the data. We are securing securing our VVIP. So whether it is IoT or mobile or anything, wherever data is generated, wherever I want to secure the data, all these type of mechanism will be required depending upon the criticality also. As I mentioned in my presentation, every mechanism is not required for everything. Basically, security mechanism implementation is dependent upon the criticality of the data, how critical data is, what is the life of the data. That is also important. You want to secure the data only for a day or a year or many years. Recently in one of the meeting, I was there in this home affair meeting, Ministry of Home Affairs meeting. There they were talking about some data, and they were planning to secure that data for 75 years. And if you're planning for securing the data for such a large period, then you have to think a special type of security mechanism implementation. If you want to secure only for a day or two or a month, then you require some different implementation. So it depends upon criticality of the data, what type of mechanism you want to use. So it is not like IoT or any other thing. It is data after all. The data may be generated by anything.
Got it, sir. Thank you so much. Thank you so much.
Sir, shall I ask another question, sir?
Yes, ma'am. Please.
Sir, in the
Yeah,
real
sure.
life, I want to encrypt the data for a while, just to sender and the receiver. What type of algorithm or the particularly algorithm I should use, sir, rather than securing for 75 years?
As I mentioned you, in our system, you are doing the risk analysis. And on the basis of risk analysis, you are defining the criticality of the data. So on the basis of that, you are deciding what type of implementation is required. Security mechanisms are required. So when you are transferring the data, let us say from one place to another
नहीं
place,
मैंने नहीं डाली आप
and that life,
हाँ मैंने ग्रुप
that
2 का
life
डाला
may be very short life,
जी
but that data is highly critical, highly
क्या सर
sensitive.
टीचर्स
So
ग्रुप में डाल दी थी मैंने
certainly you require a strong implementation, this security implementation, because data is very critical, life may be very less. Basically, everything depends upon risk analysis. So that is what it is not like you can apply anything, everything on anything. So you have to do risk analysis. On the basis of risk analysis, you are doing this categorization. So like level 1, level 2, level 3, level 4. And there you are doing impact analysis also. Like this is the data. If this data is exploited, so what is the impact of this exploitation? So all those things are calculated. And then only you are having that implementation mechanism. Recently, there was a meeting, you may be aware, G20 meeting was there.
Yes, sir. Yes, sir.
That data was hosted on some cloud. Whatever security mechanism they were there on those clouds, they were there for normal purpose. But what we analyze at the end, that those security mechanism, those implementations, they are not sufficient for G20. So extra security mechanism were deployed for that. So it is based upon the risk mechanism, risk analysis.
Okay, sir. Got it, sir. Different algorithms are there depending upon the purposes.
Exactly.
Thank you so much.
Dear participants, please unnecessarily unmute your mic. Please mute your mic because it disturbs the proceedings. Other participants can interact. Thank you, participants. You have asked wonderful questions which gave light to everyone here about the topics and issues as we. Respected sir, there is a one question regarding the security level, the preparedness of the level of the preparedness of on security by the government of India with respect to changes in the technology like quantum computing and AI. And people are actually recently there was one conference organized by Tamil Nadu government in Chennai in Trade Center, where most of the vice presidents of different software industries were called and AI related companies were called, and the chiefs they were telling that India the entire industry is in the confusion because of the emerging technologies which is threatening, and they are not able to still find out the things exactly. How prepared India is about it, sir?
Basically, government is also working in that direction, and we are also working in emerging tech also, and parallelly we are working and preparing ourselves about the threats of this emerging technology. And that is why we are preparing ourselves that how we can declare something that really it is secure. So for that we require this verification and validation mechanism. You may be aware that there is one standard, ISO IC standard 15408. It is a common criteria standard, and there are 33 participating countries. India is one of the country. So there all such type of critical devices, they are tested and certified. So in India also we are having the laboratories, we are having certification body where we are doing common criteria testing, evaluation and certification. And these certification, they are mutually acceptable. So if India has certified some product, that certificate will be valid in other country also. So in common criteria, all such type of sensitive products are test audited and certified. And on the basis of this sensitivity, there is the mechanism and methodology where some specifications are prepared, testing specifications. And those testing specifications, they are mutually prepared and agreed by the countries. And then every country are using those specifications only for testing purpose. Same thing was there in our present available mechanisms, like all those crypto algorithm, crypto module. So there are specifications for testing. Those specifications, they are available. So all these modules, they are tested as per those specifications. So same thing is planned by government also, like in AI, STQC is also working. STQC has prepared a certification scheme. We are doing one pilot project for testing, auditing of AI-based product. Parallelly, we are working on the test audit of AI-based system also. Basically, here both audits are required. Audit is required at product level also, the real output, and audit is required at system level also. So same thing is applicable in post-quantum scenario also. So in post-quantum also, the audit will be required at backend also, like wherever developments are going on, whether those developments are in secure environment, and then finally whatever deliverables are there, whether those deliverables are secure. So both the things are required, and there also some progress is there. Many of the organizations, they are working in that direction. In HTQC, we are also trying to have the facility in future. So something is there, some progress is there.
Sir Rajendra Vyas, you can raise. You have been unmuted, sir. Please, you can have your doubts clear. Rajendra Vyas, sir. Yes, please. You can unmute your mic, sir. We have allowed that. We have permitted, sir. You can unmute. It is in the bottom. The left corner of the bottom, sir. Yes. Sir, your mic has not been unmuted. Yes, sir, you can unmute. Rajendra Vyas.
Some insurance plans we have for 60 years or 80 years, 100 years. So that can also be covered in the crypto form, sir.
What is your question? I am not able to clearly understood. What is your question? Please repeat.
There, sir, insurance plans are there for up to 100 years, 99 years, 100 years. So the data will be valid for them also, because we are having our personal measures to control the data. So it's in a public domain now.
Basically, there is no direct answer to this question. Basically, as I mentioned you, it depends upon the data, and now because of the data protection bill, further they will be constrained whether somebody can store the personal data just like that. So there another mechanism will come into picture, that is anonymization. So it is different than the security, different than encryption. So in data privacy, it is anonymization. So, and it depends what type of anonymization is required. So one is recoverable and one is non-recoverable. So there are some of the anonymization which need to be recoverable, and there are some anonymization they need not to be recoverable. So wherever you are having such type of thing, like you mentioned, insurance and all those things, these things are very personal. So this is a personal data. So that control of personal data as per the government rule lie with you. You are giving the consent to that personal data. Okay, and wherever you are giving the consent, then whether that data is securely transferred. So their security come into picture then.
Thank you, sir.
Wonderful, sir. Yes, sir. Yes, next participant.
Okay.
Is there any other question? Any other question? Dear participants, the one more question. 3 more minutes are there. If before that, please, you can, because the next session will start by 3 o'clock. Sorry, 3:30. Next session will start by 3:30. Sorry.
Sir, another sir, cryptography is helping a lot, no sir? Then this aspect to secure the data by sharing with the multiple parties and.
Yeah. Please repeat your question. There is some noise. I think there is noise.
Hello, sir. I repeat, sir, blockchain technology is a very useful technique for such.
Yes.
Sir, blockchain technology is currently used with the multiple hashes and all. This will be a more secured version to secure our data.
Basically, as I mentioned you, we can't say that whatever technology is there, that is the only technology which is more secure. So here also we can't say that blockchain is more secure. They are hackable. So they are also vulnerable. Number one. Number two, it depends upon the uses. We can't use blockchain everywhere. But in some of the scenarios, certainly we can use blockchain. They are very popular, very useful, but not at every place. But all these system, as I mentioned you, the system based upon our conventional cryptography, all system, they are hackable. It depends upon what type of implementation you are having, what type of mechanism you have implemented in your system. What is the strength of the key? So it depends upon many of the factor and method. In some of the implementation, there was a requirement of like we should have two-factor authentication. And there in two-factor, one factor was digital signature. So what was happening? Username, password, and they were digitally signed and were going to the server. And some person in the middle, man-in-middle attack, they can capture this, and then there can be replay attack. Because that packet is there. In that packet, you are having username also, password also. You can do the replay attack. So though you are using digital signature, still it is not secure. So it depends how you are using digital signature. So their challenge response mechanism is required. So there will be the challenge. The response will come from the server, and then that data will be encrypted. Then that username password is going to the server and then validated. So there, this replay attack is not possible. So what I mean to say here by giving this example, it depends upon how you are implementing a particular mechanism and where you are implementing. Okay.
Yes, sir.
Okay, so
yes, sir.
It is 15:31, I think. So
yes.
Thank you
Yes,
all
sir.
from my side.
Sir, thank you very much on behalf of St. Joseph College of Engineering, on behalf of our team, on behalf of participants who actively participated in discussion with you. And we had a wonderful time with and discussing about various technological challenges. Thank you. Thank you once again, sir. Thank you all. Thanks.
Thank
So,
you all.
sir,
I
yes, sir.
enjoyed.
One more, sir. Please a minute, sir. So we'll have a photo, sir. Please switch on your camera. Just we can
Okay.
take photo. Yes, sir. Yes, sir. Participants are requested to switch on the camera. Unmute the camera. Please unmute. Don't unmute your mics during the sessions. Please see that your mics are always kept unmuted. Unless otherwise you want to have discussion with the experts or you want to tell something. Please, all the participants are requested to switch on the camera. Even you may be on the move because it's a time when you will be leaving from office and all these things. Please, all of you are requested to switch on your cameras. Your participation will be registered here because we'll create a videos. All these things will be available as a record. Thank you, sir. Expert sir, Mr. Suresh Chandra sir, thank you for participating. Participants, the another session will start in another 2-3 minutes. Please stay on the line. Please be connected. We will start the meeting immediately. The next expert is joining. Sir, Mr. Sairam Dore, sir. Sairam Dore, sir.
Can you hear me?
Yes, sir. Yes, sir. Welcome, sir. Welcome, sir, for this wonderful discussion. Thank you, sir. Welcome. We will have a formal welcome and your profile will be discussed. Then you will have a your session, sir.
Yeah, sure.
Yes, sir.